Hello, welcome to Graphing Motion Part 1. I'm going to see if I can do all the parts of this problem in one video. I may have to break it down, but let's see where we go. So here we are. We have a graph, and the question is asking to describe motion during each of these intervals. So just for the sake of understanding this, you can see that I'm breaking down into the 4 parts, just like that for now. So during the first 10 seconds, as you can see, the first thing I want to notice is what is this? This is a graph of velocity versus time. And you can see that right now from 0 to 10 seconds, I'm maintaining a velocity right here of 10 seconds. So this is constant velocity. V of 10 meters per second, like that. Okay, next. Right here we're going from 10 meters per second to 15 meters per second. So we're changing our velocity right here. So we're increasing our speed. So this is an acceleration. And we're basically increasing our velocity. So I'll just write a note. So we're just describing the motion. So this would be speeding up. Then from 20 to 30 seconds, notice that we're maintaining our speed. We haven't changed it. This is a constant velocity at a faster speed of 15 meters per second. Now we are going forward in all of these, by the way. These are all forward. The reason why I know they're forward is because we're in the positive axis this whole time of the velocity. So not only are we having constant speed right here, but we're going forward at 15 meters per second. And then right here, we're going from 15 meters per second to 0. This is an acceleration because we're changing our velocity. We're also decreasing speed because we're going from 15 to 0. Sorry for the poor penmanship. It happens to go with this writing stylus. We're still going forward because we're still in the positive x-axis. Or in other words, this whole area, I'll erase this in a second. Anytime the velocity, the line of the graph is above this x-axis, it's going to be positive. So let me just erase those so I can get those back. If I had the line down here, this would all be backwards. So this is forward. So that's our motion. Let's go on to the next part. Describe the acceleration of each of the 4 parts of motion. Okay. Right here, we're not changing our speed. We're maintaining our speed. So there's no acceleration here. And if we did that quantitatively, that's a 0 acceleration. Now from here to here, Part 2, notice that we're changing our speed. Our initial velocity is 10. Our final velocity is 15. And notice that we do this in an interval of 10 to 20. So my interval, so my delta t, this is where you have a case where your initial time is not 0. I'm going to jump ahead and just say my interval is 10 seconds because I know 20 minus 10 is 10. Acceleration is basically the slope. So if you notice, final minus initial, final minus initial. We're basically taking the slope of this. With that said, we have final minus initial. So final's 20 seconds. So notice that that's where we are. Minus initial 10 seconds. And then what we have when we reduce this is 5 over 10 gives us an acceleration of 0.5 meters per second squared. So anytime you want to find an acceleration of a velocity versus time graph, you take the slope. That's right. The other important thing is you need 2 points for a slope. Notice that I used 2 points, not one. I didn't do, 20 seconds, 15 divided by 20 seconds. That's not what I did. I took a slope. Part 3, same thing. We're maintaining our speed over time. There's no acceleration here. Acceleration. Sorry for the terrible writing, but you get the idea. That's a 0. An O. Oh boy. Okay, this is embarrassing. Let me just fix this. Okay, no acceleration. There we go. A equals 0. During this interval, there is no acceleration. Now let's calculate part 4. We're going to get the slope again. So let's take the slope of that and let's see what we get. So acceleration, so final is 0 meters per second minus initial, 15. The final time is 36 seconds minus the initial time, 30 seconds. We get negative 15 meters per second divided by 6 seconds. So what we get is 2.5 meters per second squared. So notice that, first of all, anytime you make a negative slope, well, I should say a slant down like this, you get a negative slope versus a positive slope. So first of all, just by looking at this number, I can even know that this is a negative slope and this is a positive slope. The other thing is the steepness. Notice that this one has a higher acceleration. Higher accelerations are much steeper than this one, like right here, which is a lower acceleration like that. So this just means you're speeding, slowing down, and this means you're speeding up, and both of these are forward. Very good. All right. Well, let's move on to the last one. Okay, for this one, it wants to know the displacement. Anytime you want displacement of a velocity versus time graph, remember that's going to be the area under the curve, okay? Because basically, just a quick reminder, velocity is distance over time. But if I rearrange this equation to solve for distance, velocity times time, that gives me a displacement. So for each of these, I'm basically find the area for this. But I'm going to break it down into shapes. So notice that these are not nice shapes. So actually, I'll keep that one a triangle. So basically, this just becomes a geometry problem. There we go, different than 4. Okay, so let's solve for each section. So I'll do this section first in green. The displacement of 0 to 10 seconds, so I'll just call this 1, okay? 1. Well, it's different. Anyway, I take the area, so notice I'm going to look at this, and I stop at 10, and this goes up to 10. So displacement, delta x if you will, yes, I switched the symbol, but it's the same idea, is going to be 10 meters per second times 10 seconds. My displacement is 100 meters. Now, we don't know where we started or ended, we just know the change, which is that. So part 2. So for part 2, we have 2 triangles, if you notice, right? We have, 2 parts. We have this part here, and this part. So I know this already. We just calculated this. This whole shaded area is 100 because from here to here is 10, from here to here is 10. So for part 2, basically I'm going to add 2 and 3 together to get my total. Number 2 we just calculated, so I'm going to go ahead and do that as 100 meters plus 3. This is a triangle, so I have to use 1/2 the base. The base is 10. So from here to here is 10. And the height here is 15, or 5. So you notice I dropped the units, that's okay. But let's go ahead. So this will be 5. Now, I'm just going to be repetitive. It's 5 because the difference between here and here is 5. So it's not 15. I almost wrote 15. It's a common mistake. But just to let you know. So from here to here is what we want. And that's the 5. That's where that comes from. Okay, so 100 plus 5 times 10 is 50. Divided by 2 is 25 meters. There we go. It becomes 125 meters as the displacement for that section. So now we're going to do the same thing with this. We're going to figure out the area underneath here and here. I like rectangles, they're nice and easy. So for number 3, if you will, same thing. I'm going to do 4 and 5. So 4 plus 5 will give me the total area. 4 we know. 4 we don't know. We're going to find the height and the length. So this is 10. If we use the units, it's seconds. This is the seconds, and then this is up. This is again 5. Like that. And then plus this. So just to be repetitive, and you can see this from here to here is 10, from here to here is 10. That's where the 100 goes, but I'm just going to write it out just because. So what we get? It's 150. Hope that wasn't too fast. 50 plus 100, 150. Alright, and then the last one. Ooh, I don't know if you can see the yellow. What I'll do is I'll do this for, yellow's not going to work at all, right? There we go. 4. Now 4 is going to be a triangle, so from here, so I have 30 to 36. From here to here is 6. So I'm going to, I called this, 6 anyway? So 6 seconds times, so 1/2 the base, it's a triangle, so it's going to be 1/2 the base times the height. I'm just going to make some more room and just write it out appropriately. So 1/2 the base, which is 6 seconds, times the height. The height from here to here is 15. You can see that right there, so it's 15. So this one I don't know how to do mentally, so 1/2 times 6 times 15 is 45. So that's the displacement for each of the 4 parts of this graph. So just as a quick review, with the velocity and time graph, if you want the acceleration, you take the slope. If you want the displacement, you take the area. That is the biggest thing. Okay? That concludes this video.